እንደምን አላችሁ የሳፕሬ አካዳሚ ዩቲዩብ ቻናል ተከታታዮች። ይሄ በሳፕሬ አካዳሚ በፊዚክስ ስርዓት ስር የመጀመሪያው በግሬድ 12 ዩኒት 1 ቴርሞዳይናሚክስ ሲሪስ ውስጥ የሚኖር የመጀመሪያው ቪዲዮ ይሆናል። በዛሬው ቪዲዮአችን የምንከታተለው ነምበር 1 ኢንትሮዳክሽን ቱ ቴርሞዳይናሚክስ ነው የሚሆነው። አንደር ኢንትሮዳክሽን ቱ ቴርሞዳይናሚክስ ስር ኢንትሮዳክሽን ቱ ቴርሞዳይናሚክስ የሚለውን ርዕስ ነው የምናየው በዚህ ቪዲዮ። ኢንትሮዳክሽን ቱ ቴርሞዳይናሚክስ ስንጀምር መጀመሪያ ስለ ቴርሞዳይናሚክስ ምንነት ምን እንደሚያካትትና እንዲሁም በምን አይነቶች እንደሚከፈል ነው። ናው ቴርሞዳይናሚክስ እና የመጀመሪያ ቴርሞዳይናሚክስ is simply a huge branch of physics። በራሱ ቴርሞዳይናሚክስ it's a grand branch of physics በራሱ። ናው grand branch of physics ሆኖ it has its roots ወይ ቢጊኒንጎቹ that's the beginnings of thermodynamics. The beginnings of thermodynamics ቀጥታ they were rooted in practical problems። እንደዛ ማለት thermodynamics ሲጀመር መጀመሪያ ፕራክቲካል የሆኑ ፕሮብሌሞችን ሶልቭ ለማድረግ ነው የመጣው። አሁን ምን አይነት ፕሮብሌሞችን ሶልቭ ለማድረግ ነው የመጣው ነው ስናይ፣ ለምሳሌ በድሮ ዘመን በነ ሳዲ ካርኖት ዘመን ለምሳሌ ሳዲ ካርኖት he was a French engineer። ሳዲ ካርኖት was a French engineer። ሳዲ ካርኖት who was a French engineer came up with a problem። እሱ ፕሮብሌሙ ምን ነበር? በዛ ጊዜ የነበሩ ስቲም ኤንጂኖች የሚባሉ የነዚህን ስቲም ኤንጂኖችን ሁለት ነገሮችን ለማጥናት number 1 is to increase the efficiency. He wanted to increase the efficiency of these kind of machines, and the second one he wanted to study their interactions with their environment. So in his these kind of two processes, the first one trying to increase the efficiency and trying to study the interaction of these machines with their environment led to the development of thermodynamics. Now, Zare, when we talk about thermodynamics, we talk about how huge it is and how it requires a very careful definition. Now, the previous የሆነ physics studyያችን ስለ ሜካኒክስ ለምሳሌ ባለፉት ክፍሎች grade 11, grade 9 ከgrade 7 ጀምሮ 7, grade 8, grade 9, 10, grade 12, grade 11, grade 12 ምናምን ያየነው ሜካኒክስ ስር ምን ያየነው we have seen እነዛ ክላስ ውስጥ that mechanics በራሱ we know that mechanics requires a very careful definition. It requires a careful definition of source ነገሮች it requires a careful definition of matter, motion and force. Now እነዚህ ሶስቱን careful definition ካየን we can describe a quantitative approach for mechanics. But thermodynamics ውስጥ ግን ስንሄድ in thermodynamics በራሱ this thermodynamics it requires a careful definition of thermal quantities. እነዚህ thermal quantities are quantities ለምሳሌ እንደነ heat ያሉ እንደነ temperature ያሉ ሌሎች ኳንቲቲዎች ለምሳሌ ሌሎች የሆኑት for example እንደነ internal energy የመሳሰሉት other quantities such as internal energy እና የመሳሰሉት ኳንቲቲዎችን በስነ ስርዓቱ ዲፋይን ማድረግን ይጠይቃል። now ከዚህ ውጪ ስለ thermodynamics ስናይ መጀመሪያ thermodynamics in general definition ስናይ thermodynamics is a branch of physics. It's a branch of physics that studies about energy transformations in general. Transformations in general in the form of the first form, it's the form of heat, which we represent as Q in thermodynamics. In the form of work, could be different types of work as you got. For example, it might include mechanical work, which is simply the dot product of force and displacement. It might include electrical work, for example, which is simply electrical power multiplied by time, which is voltage multiplied by the current I times t ሊሆን ይችላል. It might also include other types of work, for example, work done by gas expanding or simply by a gas in a process ሊሆን ይችላል. Either the processes might include expansion or the processes might include compression. So thermodynamics is a branch of physics that studies about energy transformations in general in the form of heat or work or other properties or other mechanisms between a system and its environment. So it's studies about the branch of physics that studies about energy transformations. Now when we talk about energy transformations, በአብዛኛው ከዚህ በፊት ያየነው, for example, grade 11 ላይ when we studied about work, energy እና ስለ power ስናወራ, we have talked about them in a sense that they are in isolated systems. Then you said no, isolated systems. But thermodynamics ውስጥ ግን ስናይ, under thermodynamics, we study them in all cases that are isolated cases and systems that are not isolated. So በዚህ ሁሉም ኬሶች ውስጥ የምናጠናው ክፍል በthermodynamics ስር ይገባል ማለት ነው. Something else that we can understand is that thermodynamics is also, it studies the situations. Thermodynamics also studies the situations in which the temperature or the state of a system changes due to energy transfers. Now, energy transfers might be into the system, that's what was the sigaba, or might be out from the system. But how do we define a system? Now, system minilona environment no. Now, the system is anything that you study, the thing that you study, or the thing that is in consideration. While the environment is everything outside the system. Now, this environment and system interact የሚያደርጉበት interface ይባላል. Now, let us give an example. Now, suppose that you are studying about a gas under compression. Suppose this guy want a can አለኝ. Now, this is my can. And suppose that I have a gas. I'm going to suppose this is my piston. The piston. And I have some sort of gases used. So these are my gas particles. Now here, the thing that I'm studying, gas ከሆነ, then my system is going to be the piston gas system, because that's what I'm studying. Now ከዚህ ውጪ ያለ every single thing እዚህ ውስጥ ያለ በሙሉ is called environment. This environment. Now the environment might interact ከሲስተም ጋር, or simply it might not. If it interacts, then we say that the system is not isolated. But if it can't interact, then my system is isolated. Also, when we investigate a system, we must make sure that the thing that under consideration might be influenced by its environment, or it might not. We can identify that when we said that thermodynamics also studies about changes in a state. For example, a state is simply the overall condition. It's an overall condition of a system. It is expressed in physical parameters. And as the physical parameters might include temperature, pressure, volume, and etc. So a change in one of these parameters is going to cause a change in state. So thermodynamics also studies about the situations and the conditions in which the state of a system might change in time. Now, the other thing that we can observe about is that thermodynamics is also successful. Thermodynamic the model so the thermodynamical model is successful. The model is successful in explaining the bulk properties of matter. Bulk properties ስንል እነዚህ በጣም these are simply properties that depend on a collection or an aggregate of matter in terms of microscopic properties of particles. ስለዛ ሌላኛው የቴርሞዳይናሚክስ ስራ ምንድነው? እነዚህ ማክሮስኮፒክ ፕሮፐርቲዎችን ማክሮስኮፒክ ፕሮፐርቲስ ከምን ጋር ማዛመድ ነው? ከማይክሮስኮፒክ ፕሮፐርቲዎች ከማይክሮስኮፒክ ፕሮፐርቲስ ኦፍ ማተር ጋር ማዛመድ ነው። ለምሳሌ ስለ ቴምፕሬቸር ስናወራ ቴምፕሬቸር is a macroscopic property ከምን ጋር ነው የምናዛመደው? with the kinetical energy of the molecules ብለን ነው የምናወራው ስናወራ this ይሄ እዚህ ጋር ያለው ቴምፕሬቸር macroscopic ሲሆን when we talk about the kinetical energy of the molecules በሞሌኪውል ደረጃ ደግሞ ብናየው microscopic ይሆናል. And thus it studies about the correlation between these two properties. Now በራሱ ስናይ ይሄ thermodynamics የሚለው is derived from two Greek words. So thermodynamics is derived from two Greek words. The first one is therme, meaning heat, and the second one is dynamis, which means power. So አሁን እዚህ ጋር ስለ power ስናወራ we know that power is simply the rate of work, or we can identify it as a transformation of energy in a given period of time. As a result, thermodynamics is simply the study of the transformation of heat in a given period of time, or the transformation of energy in a given period of time. Now, thermodynamics is a very, very broad concept ብለናል. And we also said that it is started to answer practical problems ብለናል. Now, these practical questions that thermodynamics can answer can range from really, really small microscopic questions. It can range from microscopic properties of atoms, for example, molecules, or ions, to very large scale structures. እነዚህ large scale structures, for example, might include stars, ትልልቅ ስታሮች, galaxies, or the universe as a whole. እስከዚህ ድረስ ነው range የሚያደርገው. So these kind of properties ከatoms to molecules or ions እስከ stars, galaxies, or universe ነው የሚሰራው. Now what does this imply? Now this implies that the principles of thermodynamics, which are also called the laws of thermodynamics, the laws of thermodynamics are universal ህጎች ናቸው. So they are universal ህጎች ነው ያሉት. This means that the principles, the laws, and the principles, they do not depend, these laws or principles, they do not depend on the specific detail of what's being studied, so they do not depend on the specific detail of what's being studied. So they ከትልልቁ ትንሹ እስከ ትልልቁ ሲስተም ነው የሚታዩት. So some questions that thermodynamics can answer, for example, is how can the universe end, for example? How will the universe end? For example, what will happen if you keep cooling down a substance and also some other very huge questions nature, and some other ordinary questions ደግሞ አሉ. Ordinary questions, for example, include how does a car engine work, for example, or simply how does a refrigerator cool down an object? So it can range from very, very huge questions to very, very ordinary, simple, stand questions. Now, እዚህ ጋር thermodynamics has 4 laws. እያንዳንዱ ላዎችን በሚቀጥሉ ቪዲዮዎች እናያለን. So this is our first video of under the definition of thermodynamics. እዚህ ጋር ያወራኋቸው ሁሉም ነገሮች በፒዲኤፍ ቨርዥን በየኔ ቴሌግራም ቻኔል at Sapere Academy ብትሉ ታገኛላችሁ። በዚህ at our ቴሌግራም ቻኔል ማለት ነው። ስለዛ በሚቀጥሉ ቪዲዮ እስክንገናኝ ድረስ ላይክ እና ሰብስክራይብ ማድረግ እንዳትረሱ።